Evidence of early human habitats linked to past climate pole shifts discovered by scientists. An international team of scientists has found clear evidence for a link between astronomically driven climate change and human evolution. And according to the new study published in Nature magazine, early human habitats are linked to past climate shifts, as could be expected. By combining the most extensive database of well-dated fossil remains and archaeological artifacts with an unprecedented new supercomputer model simulating Earth's climate history of the past 2 million years, the team of experts in climate modeling, anthropology, and ecology was able to determine under which environmental conditions archaic humans likely lived, the Neanderthals in other words. The impact of climate change on human evolution has been suspected, but has been difficult to demonstrate due to the paucity of climate records near human fossil-bearing sites. To bypass this problem, the team instead investigated what the climate in their computer simulation was like at the time and places humans lived, according to the archaeological records. And this revealed the preferred environmental conditions of different groups of hominins. This study considers the following hominid species: Homo sapiens, Homo neanderthalensis, Homo heidelbergensis, including African and Eurasian populations, Homo erectus, and early African Homo, including Homo ergaster and Homo habilis. So from there, the team looked for all the places and times those conditions occurred in the model, creating time-evolving maps of potential hominin habitats. Even though different groups of archaic humans preferred different climatic environments, their habitats all responded to climate shifts caused by astronomical changes in Earth's axis and wobble, the tilt of the Earth, and orbital eccentricity, with timescales ranging from 21 to 400,000 years, said Axel Timmerman, lead author of the study, director of the IBS Center for Climate Physics, ICCP at Posan National University, South Korea. To test the robustness of the link between climate and human habitats, scientists repeated their analysis but with ages of the fossils shuffled like a deck of cards. If the past evolution of climatic variables did not impact where and when humans lived, then both methods would result in the same habitats. But the researchers found significant differences in the habitat patterns for the three most recent hominin groups, that is, Homo sapiens, Homo neanderthalensis, and Homo heidelbergensis, when using the shuffled and the realistic fossil ages. Professor Timmerman said this result implies that at least during the past 500,000 years, the real sequence of past climate change, including glacial cycles, played a central role in determining where different hominin groups lived and where their remains have been found. The next question was set out to address was whether the habitats of the different human species overlapped in space and time. Past contact zones provide crucial information on potential species succession and admixture, said Professor Pascal Raya from the University of Napoli in Naples, Italy, who together with his research team compiled the dataset of human fossils and archaeological artifacts used in the study. From the central contact zone analysis, the researchers then derived a hominin family tree, according to which the Neanderthals and likely Denisovans derived from the Eurasian clade of Homo heidelbergensis around 500 to 400,000 years ago, whereas Homo sapiens roots can be traced back to southern African populations of late Homo heidelbergensis around 300,000 years ago. Our climate-based reconstruction of hominin lineages is quite similar to recent estimates obtained from either genetic data or the analysis of morphological differences in human fossils, which increases our confidence in the results, said Dr. Jae-Young Yuan, co-author of the study. The new study was made possible by using one of South Korea's fastest supercomputers, named Aleph, located at the headquarters of the Institute for Basic Science in Daejeon, Aleph ran non-stop for over 6 months to compare the longest comprehensive climate model simulation to date. The model generated 500 terabytes of data, enough to fill up several hundred hard disks, said Dr. Kyung-Suk Yoon, researcher for the IBS Center of Climate Physics, who conducted the experiments. It's the first continuous simulation with a state-of-the-art climate model that covers Earth's environmental history of the last 2 million years, representing climate responses to the waxing and waning of the ice sheets, changes in past greenhouse gas concentrations, as well as the marked transition in the frequency of glacial cycles around 1 million years ago, Dr. Ewan said. So far, the paleoanthropological community has not utilized the full potential of such continuous paleoclimate model simulations. Our study clearly illustrates the value of well-validated climate models to address fundamental questions of our human origins, said Professor Christoph Zollikofer, University of Zurich, Switzerland. Going beyond the question of early human habitats and times and places of human species origins, the research team further addressed how humans may have adapted to varying food resources over the past 2 million years. When we looked at the data for the 5 major hominid groups, we discovered an interesting pattern. Early African hominids around 2 to 1 million years ago preferred stable climatic conditions. This constrained them to relatively narrow habitat corridors. Following a major climatic transitions about 800,000 years ago, a group known under the umbrella term Homo heidelbergensis adapted to much wider range of available food resources, which enabled them to become global wanderers, reaching remote regions in Europe and Eastern Asia, said Elke Zeller, PhD student at Busan National University of South Korea, co-author of the study. Professor Axel Timmerman said our study documents that climate played a fundamental role in the evolution of our genus Homo. We are who we are because we have managed to adapt over millennia to slow shifts in the past climate. And this was published in Nature magazine, written by Connie Waters, Message to Eagle. Please leave your comments. Thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.